Hello mate and welcome back to Let's Code Season 6. This video is going to be a little bit different in that we're going to use our time in this video to do a bit of a recap of some of the classes that we've created. I appreciate that the format of the previous videos where I just show you the code and talk you through the code that I've written. For those of you who have been following along with the previous videos and have enjoyed seeing my thought process and watching me type, I appreciate that can be a little bit jarring, but what I found is that the length of the videos where I was typing the code was getting to the length where it was kind of not really feasible, because most people don't want to sit through a 45-minute video of just me talking and coding. So this is just going to be a little recap of the classes that we've written so far. This might spread into 2 videos. We'll see how long it takes me to get through it. I really am just kind of shooting from the hip on this one. I've not planned anything in particular as such. So let's just start off with the most important one, the game class. So as you can see here, the game class is literally the class that encompasses all of the other information for the game. So from the game class, we create a player and we create the map and we run the setup method. So as you can see up the top here, we've got we create our game class and then we define the constructor. The constructor is the thing that is run when an instance of our class is created. So when we create an instance of the game class, we go into this init method, and within the init method, the first thing we do is we create a player, then we create a game map, and we load the file map, which, as you remember, is one we created several episodes ago. And then we run the setup method. Now, if we jump down, the setup method is here. Setup method sets the current room, and it says to the current room, spawn the player and spawn the player in the start position. Now, if you remember, in our room class, we have a spawn player method, which has several positions. In fact, if we go to the game room class quickly, and then you can see that we've got move player, remove player, and spawn player. This spawn player method, depending on what we actually put into the arguments, so we obviously pass a reference to the player so that the game knows what it's actually going to create at the spawn point. And then the entrance is the string that we've entered, and then we check if the string reads start, then we put the player smack bang in the middle of the room. That's what these 2 formulas are for. It's just the size of the matrix divided by 2 in both the x and y coordinates. And then we've also got the positions for the north, south, east, and west entrances. And then all we do is we spawn the player in that location. Okay, so that's what that method within the game class is doing. Now, for setting up and for testing, we also create a health potion, and we spawn that health potion somewhere within the starting room. So here, this is these 3 lines of code here. We create a temporary health potion and we just spawn it within the current room just so that we can check that that is still working. This is not necessary. Once we eventually create the game proper, like we start having rooms that we want the player to navigate through and we make the game a little bit more permanent, what we might do is have a weapon and a health potion spawn in the start room, so that the player's always got a weapon that they can pick up that they can go and fight enemies with, or something like that. But for the time being, this is just proof that that actually works. This add item method within the room class actually has functionality within it. Then we've got a method just called move player, which simply tells the room class to run its move player method, and we pass a vector. It's a 2-dimensional vector, so x and y, just telling the room class what direction we want our player to move in, whether it's on the x-axis or the y-axis. Remembering that we can only move up, down, left, and right in this game. We can't move diagonally, because diagonal movement would give us an unfair advantage over other things that are spawning within the room, and it would also make pathfinding more of a pain. Okay, then we've got the exit room method. This is again another method that we would probably call from somewhere else, and we just simply say we're going to exit the room and we're going to use the exit that's highlighted here. So we're going to say there, and obviously spawn is equal to the start. And then what we're going to say is if we're exiting through the north exit, then we're going to spawn in the south of the room that we appear into, because obviously if you're going out of the top of the screen, the next room that you come into will probably be the bottom of the screen. And the same thing if we go out the south, then we're coming in the north. If we come out of the east, we're going to come in the west, and if we go out the west, then we're going to come in the east. And the vector is where on the map we're going to move, because remember that our map is just a matrix, is a grid of rooms. And we're going to, in this case, if we go out the west, we're going to go -1 on the x-axis. In other words, we're going to go left 1 tile on the map. If we go out the north exit, then we're going to go up 1, as in -1 on the y-axis on the map, and so on. Okay. And then what we're going to do is we're going to remove the player from the current room using the remove player method in the room class. And then we're going to say player move position. So we're going to move to wherever we're going to move to by vector, remembering that move position moves us on the map, not in the room, because the movement inside the room is all done by the room class. And then what we do is we spawn the player in wherever the new spawn position will be. So as I said, if you've gone out the east exit of this room, the spawn position in the new room will be the west entrance. So that's how that works. And then again, this drop item method here is here mainly for convenience, because it's easier to do it through the game class than anywhere else. And what we're doing is we're saying to the player class, run your drop item method, and we're returning the index from the inventory, i.e. the inventory has 4 items within it. Index is 0, 1, 2, and 3. So we're saying which item we are going to drop and the room in which we are dropping it. The next class we're going to look at here is the player class. And what you can see here is that, again, the constructor is where we set up all of our initial values. And the first thing we do, where we create our name, we say self._name. Remember, we use underscore as a shorthand way in Python of saying that this is a constant and it shouldn't be changed by the but directly. If you want to change it, you should use a getter and setter. Okay. And then we're saying self.setName. So if we look down somewhere in amongst all of our methods, I may have gone well past it, as I may have gone a long way past it. SetName, there it is. There's our SetName method. And we say define SetName. So this is the method it's going to call. And we say PC name equals, and then we ask for input from the player. What is your name? We set a maximum length of 12 characters. And then we remove any spaces from it as well, just in case anyone decides to start trying to type war and peace in their name. And then we check, have they actually entered a name? If the answer is no, then the default name that we're going to put in this case, I've chosen Matt, but obviously you can choose whatever your default name will be. And then we're going to return whatever the PC name variable is back to here. And then we have our class set up with the name associated to it. Then we set our initial value of our hit points, our food, and our drink. We also set cache, have an empty inventory here. That's what these 2 brackets mean. That's just an empty list. Then we have attack and defense values of 1 and 1. So if we're fighting with bare knuckles and no armor, we only have 1 defense and 1 attack. Status effects is currently an empty list as well. There's nothing in it. Our position, this again, just to reiterate, this is the position on the map, not within the room. In our map, room 2x2 is a room, and we can change which room we're going to spawn into once we have the map fully set up how we want it to. But for now, we're going to spawn in room 2x2. And then the log is where our messages that we added a couple of episodes ago, that's where they're going to appear. This is the empty list, which is going to contain those messages. Okay, so then we have a really simple take damage method, which literally just subtracts whatever number we put in there from our hit points. We haven't added any logic to this yet that makes the player die or whatever once the hit points reach 0. Then we have all of our getters. All a getter does is it gives us a way of getting hold of these values without addressing them directly. So when we say get name, it returns the name. Get hit points returns hit points, and so on ad infinitum until we get down to this one. Get icon is not a property here, if you notice. And what this is this is the method that's going to return the file, the PNG file that we want to represent our player. Now later on, we maybe change this for an animated PNG, i.e. some kind of animation that we can add. But for now, this is just a static PNG that's called player.png from within the images/icons folder. And then, as I say, we always, when we try and load a file from the hard drive, what we do is we say if ren'py.loadable and the file that we're looking for, because if that file doesn't exist, if we accidentally delete it or something, what will happen in Ren'Py is that it will throw up an error, and we want to try and minimize that. So we've got a default image, which is just a blank PNG that we will load in the absence of this player.png should we accidentally delete it. Then we've got setters, which just allow us to set our hit points, food, drink, cash, attack value and defense value, and move our position. Remember that move moves our position within the map, not within the room. Next thing we will add to inventory. If we're going to go through here and we're going to just simply pass in a game object here. This bit says is the object that we're going to add to our inventory. And we're going to check if the game object that we're trying to add to our inventory is not an instance of the game object class, then we will not accept it. We'll just say print trying to add a non-game object to inventory and we'll return nothing. Okay. If it is an instance of the game object class, then we'll add it to the inventory. Remember that the logic for checking whether or not we have too much in our inventory already is carried out elsewhere, so don't panic too much about that. But we could add it here if we wanted to. We could just say if the length of our inventory is greater than 4, then we would not accept this new item and it would do nothing else. Then we've got add hit points. Again, just a simple add hit points. Take the original number of hit points and add whatever number we input to it. Dead simple. And then in this case, we've got a confirmation, but we don't actually need to do this. What we could do here is we could actually add these to the game log. Remember that a lot of these things are never actually going to appear to the player. These are more for the debugging. So yeah, what we could do here is we could actually add these print statements and change them so that they add like this message down here where it's self.add_message, and it adds the message to our message log. So that might be something that we do in a later episode, or failing that you can do that yourself now if you wanted to. Nobody's stopping you. You've got the code that you need. Then currently all our update method does is it removes 0.1 from our food and drink every single tick. And these ticks happen every 10th of a second. So basically we lose 1 food and drink every 10 seconds. So that's dead simple. And then again, this is add message method. All it does is it takes the string that we input here and adds it to our message log list, which we show in one of our screens. Use item, again, remembering that our game objects themselves have a use method. So all we're going to do from our player use method is we're going to double check, is there actually anything in our inventory? And if there is, then we can use it and then remove it from the inventory. Otherwise, it says that we can't do it. Because, for example, if we have a shield, we can't actually use a shield. A shield is just something that stays static in our inventory and gives us a buff to our defense stats, or rather it will be when we get to that part of the coding. So we can't actually use that object in that way. So when we try and use that object, we'll just get a message saying that you can't use it like that. And then drop item simply says, we take 2 items, we check the index within our inventory, and then we check the room that we're in, and then we say if not room.drop item, because if you remember, our method drop item will return none if we have successfully dropped the item. So we're saying if it has successfully dropped the item where we told it to, then it will add a message to the log saying dropped the name of the item. And then it will actually pop it. But pop is a function within Python that removes an item from the list. It just takes the item out of our inventory list. And if we couldn't drop it, in other words, if the drop item method within the room class fails, then we will get a message saying unable to drop the item here, basically. And that is the entirety of our player class as it currently stands. Now, the map class hasn't changed since the very beginning, but we will quickly go through the initial bit. I'm not going to go through the saving the map bit because that's really just was there as a curiosity for you guys to see how to actually write to files rather than reading them. But what happens in our map class, in the constructor, we've specified a map file. Now, if you remember from within the game class, when we create a new game map, as you can see here, we just put in, it's a game map is equal to map, and then we pass in a string map with no file extensions or anything, because the map class itself does all of the rest of that for us. So we take the name of the file, in other words, map, and then we load the file. So here we've got two sets of curly braces. The first set of curly braces refers to the game directory, so that we don't have to worry about where the file is located within our hard drive. So we're saying within the game directory, inside the data folder, then we're going to use map file. In this case, it'll be map.csv. And inside our data folder here on the left, you can see we actually have map.csv right there. And then we're telling Ren'Py that it is coded in UTF-8. And then we're just saying shorthand, load it as F, so that we haven't got to keep writing this every time we load it. So we've loaded the file and we've called it F. And then we're going to say lines is equal to f.read.splitline. So we're reading every single line into this list here, a list called lines. And then we close the file because we don't need it open anymore. We've got all of the information out of it into a list. And then we create a temporary matrix. And then we go through all of our lines and we split our code, or split the code that we're reading from it using a comma, because it's a comma separated value file. And it turns it into a list of lists, basically. And then we just add it to the temp matrix. Then we load our prefabs in. Our prefabs list is the one that we created, which has actually read the data from our prefabs.xml. And then we pass our prefab data into the matrix, which will add items into our rooms and tell us what rooms to put in each place within the map. So in the case of the test map that I've been using, I've got 3 rooms, 2 of them standard 20 by 15, and then one that's different. If we look at our prefabs.xml, you can see here we've got an empty room that's 20 by 15, and then we've got another separate room called Elven Garden, which is 11 by 11, and in that room we have a health potion that's at position 4 by 3, and then we have a shield of blocking, which is a very imaginatively titled piece of equipment that's located at 8 by 5, and that will appear in the room when we run our game. So that is basically all there is to the map class. Again, I'm not going to go into the code loads and loads because we've already done that. I'm just kind of giving you an overview of how each class does what it does, so that we can actually, move on, because I appreciate that some people have been struggling to keep up. Okay, so this is just a very quick whistle-stop tour, just explaining how things do what they do. Now, the game room class is huge, so I'm not going to do that one right now. I'm going to move on and talk about some of the other classes that we've created, because the game room is going to take the longest because there's so much stuff in there. I really do need to split it down into separate things. And those of you who are paying attention can see that I've already started doing that in this file up here, matrix class. Maybe we'll cover that in another video because that is going to be a long one to explain. So let's look at the prefab class. The prefab class is actually nice and small, and it just contains the constructor, which says give us a name, a room type, a room size, any items that are within, and then any positions. Now we have 2 lists, items and item positions. So when I add 3 items to my items list, I must also add 3 item positions to my item positions list, and they must be in the same order, so that item 0 is going to be at position 0, item 1 is going to be at position 1, item 2 is going to be at position 2, and so on through the list. Okay, if we don't, that's how our prefab class is going to interpret. So if you get your item positions back to front, that's just how it's going to work. Then we take our name from the arguments passed into the constructor, as well as our room type and our room size. Then we've got our getters, get name, get size, get type, get items, and get item positions. And then that's all there is to that class, basically, this whole bit here. The rest of this code down here is actually us passing in the XML file. So we create an empty list here, and then we run this pass XML, and we pass in the file name. Then we load the file using xml.etree.elementtree, which we've loaded as a module for Python that allows us to pass XML. And then we pass that, and we've just used this code down here again, Code that we've already talked about. This is just how we turn that XML file into a prefab, basically within our prefab class. So we turn each prefab from within our prefabs.xml into an instance of the prefab class. In this case, we've got 2, but when we finish, when this game's ready to be published, there will be dozens of these because our map is pretty big. So we've got, potentially we could make a separate room for every single room and load them in like that. Or you can have just some generic rooms or generic corridors that would allow you to act as fillers between interesting rooms. So you could have a prefab for each point of interest and then just generic rooms for padding, basically. So that's how our prefab works. Our map CSV file we've already talked about. I'm not going to go into this again because we already kind of covered this, but this is basically where we tell the game where we're going to put rooms. And you can have this map as big as you want. It can be 1,000 by 1,000 if you want to. I mean, there really is nothing stopping you from having a map that is 1,000 by 1,000 in this game because it doesn't load every single room at the same time. What happens is that we only ever look at the room that the player is in. The rest of the rooms do nothing. They stay static. They're not really loaded into memory. They're not doing anything. We're only focusing on what room am I in, and when I transition room, it then looks back at the map and says, what's in the next room? So yeah, you can make this map as big as you want. I challenge you to try and make a map that's 1,000 by 1,000 and is still interesting, because I guarantee you, the player would get incredibly bored with that, unless you had absolutely outstanding artwork and every single room was unique and had different enemies and stuff in there, which this game engine is entirely capable of doing. You just have to be willing to put in the time. But yeah, there's a lot of time and energy putting into there that you might be wasting because you have to try and keep a game engaging. Otherwise, really, what's the point? So now we go into our game object class. This is where things are a bit more interesting because we do several things in this file. Because it's init0 Python, this is where we're going to load our abstract base class stuff. So we load ABC, abstract base class, and abstract method from the module ABC so that we can use them, because if you remember, our game object is an abstract class that we then use as a parent class. And then in these following 3 lines here, we've just removed some keyboard shortcuts that we can actually use W, A, S, and D as our movement keys from within the game. And as I said before, this may trigger some people who think that you should never tinker with Ren'Py's default key map, but those people can chew off as far as I'm concerned. It's my game. I'll do what the hell I want. Okay. And now we create our first abstract base class called game object. And what the abstract base class requires is a name, the amount or a value that's going to be assigned to that game object, whether or not it's carryable, and an icon file name. And then as you can see, we just set those to be the internal values of our fields within our class. That's what these 4 lines are for. And then we have our getters that return whether it's carryable, what the amount is, and what the name is. Then we have an abstract method, which is really simple. It just has use. So use is an abstract method in this class, which doesn't actually need any code in it. You should really just put pass in here. I've put this string in here just to kind of iterate that this is a method, but this method does nothing. If you try to create an instance or a derivative object from this, so if my health potion object did not have a use method, then what would happen is that we'd get an exception, because when we declare an abstract method, what we're saying is that everything that inherits from this base class must have its own use method. You cannot have a game object without a use method for it. Even if that use method contains no code, we must have a use method. That's what we're saying when we create an abstract method like this. Then we have the icon, and just like with our player class, it loads a file, or it tries to load a file. We put a string together here for our file name, and then we check whether or not that file is loadable. And if it is loadable, then we'll return the output string as our value for get icon, because remember this is a property. And if it's not loadable, then we'll just return a default image instead. So that again, Ren'Py won't throw an exception. It will always have something to put on the screen, even if it's an empty PNG file. Next thing we got is our pickup method, and all we're doing is saying player because we're actually talking about the item itself. So when you pick up this item, the player must be told, well, we must tell them who is picking it up. So in this case, it's going to be the player, which we would pass in. And then we're saying if the item is carryable, then we're going to add our item to the inventory. Or in this case, we're going to say add myself to the player's inventory, because remember, this is from within the class. And then we're going to add a message saying blah, blah, added to the inventory. And then we're going to return true to say that, yes, I have successfully been added to the inventory. If we cannot pick it up, then it will immediately go and call the use method, which is this one here. Obviously, this is an abstract method. This is not an abstract method. This is a method that will be used by every single game object. Every single game object will use this exact method rather than having to have their own bespoke one. Okay, so it's a little bit complicated to understand if you don't understand the concept of abstraction, but hopefully it's fairly clear. Notice that when I create the health potion class, it inherits from the game object class. In other words, it takes all of this goodness and adds to it. We can now say we need to define our use method as we have done here, but we don't have a pickup method, because when we say health potion.pickup, it will go and use this code instead. Okay. So in the constructor for our health potion class, all we need to say is the amount. So I want to create a health potion. It's going to have a value of this, and then it sends that amount into the constructor for the base class with the following extra information. We know it's going to be called health potion because it's a health potion game object. It is picker-upperable, so that's why that says true. And then the icon that it's going to use is going to be called healthpotion.png, because that health potion bit there is going to be put into this string here where we have get icon again. So get icon is not an abstract method. It is a property from within the class that can be used by every derivative class. That is how that one works. And then exactly the same logic applies for our food item and our drink item. Our armor item is exactly the same, except for its use method just returns true because we can't use it. The armor is just something that's going to sit in our inventory and give us a buff. And then obviously these are the classes that we created, health potion small and shield of blocking, that actually add instances of these items up here into our map so that we can declare them. That's basically all there is to the game object class. Entities, we haven't really done much with them for a while, but again, the entity is going to be for things like NPCs and enemies. Maybe we'll use entities also as things like destructible obstacles like rocks and things like that as well. They would be entities and not game objects because they can't be picked up. They can be attacked and destroyed, and they will block the player's path, but they shouldn't be collectible because that would be silly. That would just be a waste of inventory space. So again, our entity is an abstract base class. It takes name, it takes is alive, it takes can attack, it takes can use, can move, and then an icon. These values here are all booleans, i.e. they are true or false, and we set them depending on the conditions of our entity. So for example, if it's an enemy, then yes, it's alive, yes, it can be attacked and can attack. It cannot be used, but it can move. So these are the conditions that we would be allowing the player. So for example, if this was an NPC instead of an enemy, we'd still have is alive and can move, but we would remove can attack so that it can't attack the player and cannot be attacked, but it can be used, i.e. it can be interacted with. So you could open a dialogue with that NPC, for example. And then the icon, again, is just the file name that we're going to use to represent this entity when it's on the screen. And then we've got a series of getters. Notice our get icon method is pretty much identical to the get icon method from our game object class. It does exactly the same thing. It creates a string from the information that we've provided, and then it checks to see if we can load the file name that's represented by that string, and if it can, then we'll return the file name for that, and if it can't, then it will just go straight to the default.png. Next thing, we've got set position, fairly self-explanatory. We type in set position and it sets its position. And then we've got an abstract method called update. Again, remember, abstract methods are methods that must be added to the derivative classes. So our goblin entity that we've got down here must have an update method and it must have a move method, because they are both abstract methods. The code that follows is largely irrelevant because we're never going to use this code inside our abstract classes. And then from our entity class inherits the goblin class. The goblin class, as you can see here, inherits from entity, and then its constructor says whether or not the previous things are true. So we've got a name for it, which we've used when we put in create an instance of our class. So I'm getting my models worded up, talking too fast. When we create an instance of the goblin class, we provide a name and we provide a level. That information is passed into the constructor for the parent class, which takes a name, is alive, can attack, can use, can move, and then the icon, which is going to be goblin in this case. And then we're setting escape priority and attack priority. These are part of the AI, which we haven't really looked at yet. Then we've got the hit points. As we can see, the hit points formula is dead simple. Its hit points is 90 plus level times 10. So if it's a level 1, it'll have 100 hit points. If it's level 2, it'll have 110 hit points, and so on. It gets 10 more hit points every level we increase. And then its current waypoint is 0, 0, but this is just a number that's going to be changed almost instantly further down. Then we've got the getters. Again, exactly the same. They just return the property to which they refer. Then we've got our set waypoint. At the moment is a very simple formula that just says if we are looking for a waypoint that is not the player, which is important because remember we wrote the pathfinding algorithm a while back that will navigate our entity to the player. However, if the enemy is trying to get away from the player, if it's trying to flee, it will basically say if the player is to the left, move to the right. If the player is to the right, move to the left. If the player is above us, move down. If the player is below us, move up. That's all this method does. And then as you can see, because this is a child class of the entity, we must have an update and a move method, which currently, because we haven't added any AI or logic to this yet, really, they're just empty classes with the word past in them so that Ren'Py doesn't throw a hissy fit, or rather Python doesn't throw a hissy fit when we try to run this code. Because if we didn't have an update and a move method that like this, it would just crash. Okay. And then we have our main user interface screen. This is the screen that basically contains all the other screens. As you can see, it has a background image, which is, funnily enough, the image in the background. Icon screen, this is the representation of what is in our matrix for our room. So this is going to be where the icons for the player and any game items that we have are. Then we have a player HUD, which is where the top bar is going to be. That's the top of the screen is going to be a bar which contains where we are and our hit points and our food and our drink. Then we have the log, which is the little ticker that shows any messages that are contained within our message log. The inventory screen is the little bar at the bottom of the screen which shows any inventory that we have picked up. And then we have if game.currentRoom is on player exit. In other words, if the player is standing on an exit, then we will show in the middle of the screen, press E to use the exit, whether it's north, south, east, or west. That will change depending on what we are standing on. And then we also have key E. In other words, press the E key to carry out this action. This action is game.exit room. In other words, leave the room. And then we set the keyword argument property room exit equals, and then what exit the player is actually on. Then we have our keyboard's shortcuts, our key bindings, W, S, A, and D for up, down, left, and right, which invoke the function move player within the game function, the game class, even with the vector for the position that the player wants to move in. So are we moving up or down or left or right? And then we just have a button in the screen at the moment with next on it. This button doesn't really do anything at this point. It just returns none back to our script file just to progress the loop once more. This may or may not be necessary. I'll probably remove it later on when we have more stuff going on. But this is just kind of there so that we have some way of getting the screen to move on if we get stuck, basically. So that's basically everything apart from the game room class. I'll probably cover that in another video because the game room class is very much a work in progress. We're adding an awful lot of code to it, which is why I want to split it into a separate class and have the actual matrix itself be a separate class that has lots of its own instructions so that we don't have to keep making the game room do everything. A good rule of thumb when you're programming is that any class should only be responsible for one thing, and any method should also only be responsible for one thing. So if you find yourself writing methods that do multiple things, probably should be split down into separate methods. And the same thing for classes. If you find that your classes are becoming bloated because you're trying to add too many things to them, then you probably want to split them into separate classes. In the case of this game, what we've got is that our game room contains a matrix, but all of the logic for the matrix is currently contained within the game room class, when we probably, for the sake of convention, we probably should be moving that stuff into its own class, an actual matrix class, which has all the functions that are specific to manipulating the matrix in them, and then we invoke them from the room class. So that's something that I'm possibly going to do moving forward. I'll probably make a video on that if I decide to do it. There is a lot of refactoring that needs to be done because of the way we've written the code, and this is one of the drawbacks of coding in any instance where you find, hang on a minute, I need another class here. And this is why the planning process needs to be really prioritized, and you do need to spend some time on it, because the amount of time that it will take to refactor the code, the deeper you get into the code, the more chance there is of screwing things up. So we're already quite deep into writing this game engine now. So if I do decide to use the matrix class, it will have to be very, very thoroughly checked, because so many of our functions rely on that matrix that it's really going to be easy for us to break things beyond repair. Anyway, thanks very much for watching this unusually long video from me. Hope you found something useful in that. Let me know what you think in the comments below, and I will see you in the next one. But until then, you take damn good care of yourselves, all right? Bye-bye.